In this problem, we are given the bar AB that is supported by a frictionless inclined surface at A. As shown in the figure, if P is equal to 5,000 pounds, we are tasked to calculate the reaction at B. Now to solve this problem, let's draw our support reaction at B. Since this is a hinge, it would induce a force that is both vertical, let's call this B sub y, and horizontal, let's call this B sub x. And on the normal surface at A, that has a force that is perpendicular to the surface that would induce a normal reaction. Let's call this R sub A. Now we try to draw a vertical line as our reference. Knowing that this angle here is 30 degrees, you can prove by geometry that this angle here must also be equal to 30 degrees. Now this force R sub A, we can break this down into components. This has a component going up that is a value of R sub A cosine of 30 degrees, and a horizontal component that has a magnitude of R sub A sine of 30 degrees. Now we can take summation moment at point B equal to 0, considering counterclockwise to be positive. So we have force B of 5,000 pounds times its moment arm distance of 5 feet times cosine of 10 degrees. And since this would induce a clockwise moment, so it's positive. And then for the horizontal component of R sub A, that would induce a counterclockwise moment, so it's positive. So plus R sub A sine of 30 degrees times its moment arm distance, that is equal to 10 feet sine of 10 degrees. So this distance here is 10 sine of 10 degrees. And then minus the moment induced by R sub A cosine 30 degrees, that would induce a clockwise moment, so it's negative. So we have R sub A cosine of 30 degrees times its moment arm distance of 10 feet cosine of 10 degrees equal to 0. So we have a single equation with one unknown. We can solve this using our calculator. So we have 5,000 times 5 times cosine of 10 degrees plus R sub A times sine of 30 degrees times 10 sine of 10 degrees minus R sub A cosine of 30 degrees times 10 cosine of 10 degrees. This is equal to 0. Shift solving, we get R sub A equal to 3,213.94. Now to solve for dx, we just take summation of force horizontal equal to 0. So we have a horizontal component of R sub A that is 3,213.94 pounds sine of 30 degrees minus B sub x equal to 0. So we have B sub x equal to R sub A times sine of 30 degrees, that is equal to 1,606.97 pounds. And to solve for B sub y, we'll just take summation of force vertical equal to 0. So we have negative P, that is negative 5,000, plus B sub y plus R sub A of 3,213.94 cosine of 30 degrees, all equal to 0. Solving for B sub y, that is negative 5,000 plus B sub y plus 3,213.94 cosine of 30 degrees, that is equal to 0. We get B sub y equal to 2,216.65 pounds. And to calculate for the net reaction at B, we'll just take the square root of bx squared plus by squared, or we're just doing a Pythagorean theorem on this triangle here. Knowing that we have B sub x and B sub y, to get the net resultant, we apply Pythagorean theorem to solve for the net reaction. That is B. So force B, or the reaction is B, that is equal to the square root of 1606.97 squared plus 2216.65 squared. That is equal to 2737.86 pounds. And this is our final answer.